Okay, so we're going to take the derivative of the inverse sine function. Y equals arcsin x. I'm going to take the sine of both sides. So we have sine of y equals sine of arcsin of x. Now the sine of arcsin of x is just going to be x because sine and arcsine are inverse functions and they're going to cancel each other out. So we're going to get x on the right hand side, sine of y on the left hand side. Take the derivative of both sides with respect to x. So we have d dx of sine y. And notice that we're taking the derivative with respect to x of a function which is in terms of y. So we're going to have to use chain rule there. And on the right hand side we just have derivative of x with respect to x, which is just going to equal 1. So to chain rule, we're going to say dy dx times d dy of sine of y. So we can just go ahead and complete that derivative. Say dy dx times cosine of y equals 1. And then looking over here, we have dy dx. And since we have a function up here, which is it's a y equals arcsine x, dy dx is going to be the derivative with respect to x of arcsine of x. So we're actually going to want to solve for dy dx. To do that, we're just going to say dy dx equals 1 over cosine y. So now we're at an impasse because generally speaking, the inputs that we're going to have are going to be the x. We're going to have the independent variable with which we can input, and then we're going to use our function to find dy dx. So we're going to want to put this function dy dx in terms of x, but it's currently in terms of y. So in order to do that, we can actually go up here ourselves a little side area and say, okay, sine of y equals x. Using this line right here. So sine of y, sine in general stands for something with triangles. It stands for opposite over hypotenuse. So since we have opposite over hypotenuse, what equals x, we can say, well, let's say the opposite side is equal to x, the hypotenuse is equal to 1. Go ahead and draw a triangle. So we have sine of angle y, opposite side equal to x, hypotenuse equal to 1, and then using the Pythagorean theorem we can say opposite squared plus adjacent squared equals hypotenuse squared. Oop, on the edge of my board. Erase that, make it nice and neat. Equals hypotenuse squared. Alright, so then we have the opposite equals x, so we have x squared. We have the hypotenuse, which is equal to 1, so we could say plus adjacent squared, hypotenuse equals 1 squared, which of course is just going to be equal to 1. So now we can solve for adjacent squared, this side. Adjacent squared equals 1 minus x squared. Adjacent is going to equal taking the square root of both sides, is going to equal square root of 1 minus x squared. So we have here square root of 1 minus x squared. All right, from there, we can remember that cosine in general will equal adjacent over hypotenuse. We're looking for cosine of y. Well, we have y here, the angle y, so let's take cosine of y is going to equal our adjacent side, we just solved for, 1 square root of 1 minus x squared over the hypotenuse, which is just equal to 1. So we can just say that whole thing is equal to square root of 1 minus x squared. Now that we have that, we can replace cosine y here with cosine y here. So dy dx, zoom in for the exciting denouement, equals 1 over the square root of 1 minus x squared. And we are done.